Alright, well now on to chapter 2. We will talk about atoms and molecules, ionic bonds and covalent bonds in this. Okay, so why study chemistry and anatomy physiology? Well, we're all just made up of chemistry. We're made up of atoms and molecules, and the food that we eat, it's also just all chemistry. And so yeah, we're gonna go over chemical reactions in our bodies and how the food, medications are all composed of chemicals. Okay, so let's start out with matter. Matter is anything that you see around you, but also actually things that you don't see around you, because matter is solids, liquids, and gases. So I want you to know this. I will ask you the three types of matter. Know that solids, liquids, and gases are the three. Putting a star here. And so matter is just made up of atoms. The different types of atoms are called elements. So for example, carbon is an element, oxygen is an element, hydrogen is an element. And so yeah, atoms are what makes up the matter. And so here in the body we're seeing the major elements. So oxygen makes up a lot of our body, carbon, hydrogen, and there are the trace elements too. So these are the ones that we don't have a lot of in our body, but we still need them. Okay, so here's another thing that we need to know. What makes up atoms? Atoms are made up of these three parts. Protons. Protons, know that these have a positive charge. Protons are located in the center of the atom, the ones that have the plus signs here. Neutrons. Neutrons are also in the center parts. Neutrons have no electrical charge. So these are the ones that have the 0 on them. You can see here. So this inside part of the atom is called the nucleus, the center part. So in the nucleus, we're seeing the protons and neutrons. And then around the nucleus are these smaller particles called the electrons. And these are spinning around. Okay, so then know that electrons have a negative charge. Okay, so again, just know that these are the three parts making up atoms and what charges they have. And again, the nucleus is the central part of the atom. The nucleus has the protons and the neutrons, and electrons are spinning around the nucleus. And I want to point out here, this first circle is called a shell or an orbit, so only 2 electrons can fit into this first shell. Then the other electrons go into the other shells, the other orbits. And in the other orbits, we're going to see 8 can fit into the other ones. Okay, we need to know the atomic number of an element. Atomic number is the number of protons in the nucleus of an atom. So for example, carbon has 6 protons and its atomic number is 6. Oxygen has 8 protons, its atomic number is 8. So the atomic number never changes for an element. That's what makes it unique. And I also want you to know here, the number of protons is equal to the number of electrons in an atom. Okay, so we're going to see that a little bit come into play. Then for the atomic weight, know that this is the total weight of the atom. When you add the weights of the protons, electrons, neutrons, you get the total weight of the atom. Okay, so then next, isotopes. Isotopes are just variations of an element. And all elements have these variations. Now, isotopes of the same element have the same atomic number, but what is different is that they have different atomic weights. Because, and here it's underlined, definitely know this from the slide, isotopes differ in the number of neutrons, but they have the same numbers of protons and electrons. Okay, so here we're seeing, give an example of oxygen. The numbers that we're seeing here is the number of the protons plus neutrons. Okay, so oxygen's number of protons is 8. So this variation here, this isotope, has 8 neutrons, 8 protons. But then this one has 8 protons. So again, protons never change, but this has an increased number of neutrons instead of the 8, so it has 9. And then this one has 10 neutrons instead. Okay, but so again, the important thing is know that the isotopes differ in the number of neutrons. Radioactive isotopes are the heavier isotopes with a lot of neutrons, and they give off radioactivity. And then this radioactivity can actually be detected on medical imaging devices, but also to destroy cancerous tissue. Okay, next we can go on to molecules. Molecules, if you remember from chapter 1, this is when two or more atoms are combined. That's all the molecule is. And so here are some examples of molecules. Molecule of hydrogen, molecule of glucose, water. Okay, so what causes the atoms to combine with each other is the next thing. Okay, and so here are just some more examples of molecules here on this picture. Now, bonding of atoms, chemical bonding, is when the atoms get together. Okay, so what we need to understand is those electrons. The number of electrons determines the bonding, the type of bonding. So here we need to look at these rules first. Now the first shell, what we mean by that is that first circle where the electrons are spinning in, only 2 electrons can fit into the first circle. But into those other circles, the other shells, there can be up to 8. And so depending on the number of electrons. And in the third shell, fourth shell, can also hold 8 electrons. So let's do an example here. So I was saying oxygen's atomic number is 8. So that means that it's got 8 protons, but it's also got 8 electrons. Because remember, the number of protons is equal to the number of electrons. So the oxygen atom, and I'm doing this here, this is supposed to be the nucleus of the atom where the protons and neutrons are, but we're more concerned about electrons. So I'm going to draw this first circle, and so we have to get to 8 electrons. So only 2 electrons in the first circle, but we're not done yet. We have to draw another circle to get to 8. Okay, my circles are not very good. But now in the next circle, we have to have 6 to get to 8. And so I'm just going to put some here, 1, 2, 3, 4, 5, 6. And so here in the outermost shell of oxygen, which is called the valence shell, it has 6 electrons, but 8 electrons total. Okay, so the thing with atoms is, this outermost shell needs to be complete for the atom to be satisfied. So this is called the octet rule. If it does not have full number of electrons in its outermost shell, then it's just going to be reactive. It's going to be reactive with other atoms. So here, oxygen needs 2 more in order to satisfy the octet rule. And so because it needs 2 more, it's going to get together with the other atoms. Now, let's take hydrogen as an example. Hydrogen's number is 1, which means that it's got 1 electron. And so how many does hydrogen need to be satisfied? It just needs 1 more. Because it only has the 1 shell, so we're only looking at the outermost shell to see if it's complete. Because it only has 1, we need to add 1 more to it. Okay, so how does this work? Okay, and so here's some more examples of the electrons with the atoms. You can see here helium. Helium has 2. Helium, because it's already full, it's not going to react with other atoms. Okay, so that's an exception because it's a noble gas. Here's another example, lithium. Lithium's number is 3, so it's got 2 in the first one, and just the 1. And so how many do you think it needs to be complete if it only has 1 here? Because 8 can fit into this. It needs 7 more to be complete. And this bottom one here, this is showing the sodium. Sodium's number is 11. Okay, so we only look at the outermost shell. If you look here, it only has 1 in its outermost shell. This one needs 7 more, but we're going to see that it's very hard to pick up 7 more electrons. But if sodium gives up this extra one, then we can get rid of this outermost shell. We're going to see on the next slide. Okay, so with ionic bonding, with ionic bonding is that electrons are transferred between the atoms. So if you look at this example, there's the sodium on the left, chlorine on the right. Chlorine has 7 in its outermost shell. It's missing 1. So 1 more needed. Sodium has that extra 1. Now, if we just get rid of that extra 1, give it to the atom that needs it, then the sodium's outermost shell, just imagine that gone. So if we imagine this gone, now you have this outermost shell that's left over. Now this has 8 electrons. And so now sodium is satisfied, but also chlorine is satisfied. Okay, and so this next slide is just talking about what I just said. So know the definition of ionic bonds. This is when electrons are transferred from one atom to another. Then the next type of bond, the covalent bond. So here, this type of bond is when electrons are shared instead. So in order to share electrons, the atoms have to stand very close to each other. Okay, so we're seeing here the hydrogen molecule. Because each hydrogen needs just 1, well, if they just stand next to each other, then they can just share those electrons and have the complete outermost shell. For covalent bonds, this occurs when the number of electrons, the valence electrons, is similar. If you're wondering, what's the difference between, ionic versus covalent bond, but just really know that covalent bonds share electrons. Ionic bonds is the transfer electrons. One more thing, covalent bonds, are the strongest. Definitely know that.